All right, this is going to be a relatively short video. This one's going to be about the regeneration of axons. And it is all about those neuroglial cells between the Schwann cell or the oligodendrocyte. So just to refresh, we talked about these things called oligodendrocytes. They are in the central nervous system. They are they do the job of what the Schwann cell does in the peripheral nervous system. And it's really important you remember that the cell body is not on the axon for these. It is simply these little arms that reach out and provide myelin, wrap around the axon and provide myelin at different places. So multiple different oligodendrocytes, or I'll just say it another way, a single oligodendrocyte can provide myelination on multiple different axons at multiple different sites. So that is an important feature, as opposed to what's on the next slide, which is this next slide. We're looking at a Schwann cell. All right, again, they're going to wrap around the axon. They provide, again, myelination. But the thing is that's different is each one of these is an individual cell. This is a cell on its own, unlike the oligodendrocyte. And this makes a big difference if there is a damaged part in or on the axon. So again, I hate the way a lot of times books write things a little bit too scientifically, and it just can get confusing. But if we have an injury to an axon, now before we get there, let's just say neurons do not go through cell division. Remember, they can have, for instance, a sensory neuron or even a motor neuron that is going to go down to the muscle in your big toe. You know, it's going to be several feet long because it's going to go completely along your leg up into your low back, and so it would be almost impossible for to have that divide and work out well. So neurons do not divide, and if the cell body of a neuron is injured, the cell usually dies. That is not a good thing to have an injury of the cell body. It is bad, like it says. Woo. Now, the axons are a little bit different. When the axons get injured, if it's in the peripheral nervous system, there's a good chance that it will regenerate, and this happens all the time. Anytime you cut yourself, you're going to damage some little distal ends of axons or whatever. But if you have a injury to the axon, as it says here, it may regenerate. I'm not saying it always does, but it might. As opposed to the central nervous system, where if something happens, regeneration is unlikely. And it all goes to the difference between Schwann cells and these weird word cells called oligodendrocytes. All right. So because the Schwann cell, and the way they write it here is they'll say because the Schwann cell has a neurolemma, it can regenerate. And all that's saying is the neurolemma, remember, all that is where the cell is, the cell body. So if I drew a cross section, you know, and I had this area here, and it's layer upon layer upon layer of myelin sheath here in this middle part, that's the myelin sheath. This bubble on the outside where the cytoplasm is and the nucleus and all the other, you know, normal cell stuff is on, they call it the neurolemma. So what happens is if I have damage on an axon in the peripheral nervous system, the Schwann cell will remain where it is. And that allows for the axon to know where it needs to go, as opposed to if in the central nervous system in these oligodendrocytes, remember, if I had an oligodendrocyte here, I might have an arm coming out here forming a little area of myelin on this axon, one over here, and forgive me, trying to draw on this is a tough thing. So let's say, you know, I've got these axons here. So I'll put one here coming from another oligodendrocyte, whatever. So this is an axon here. And let's say that something happens to this axon and it gets cut. And so the axon will start wasting away. And all that'll happen is this arm, since it's no longer holding on to an axon, it's going to be pulled back into the cell body. And so basically it disappears. And whenever this would try to figure out where to go, it has no idea. As opposed to if I have a layer upon layer of Schwann cells like this on a particular axon, and this axon running this way, we'll say it's going this way, I have some kind of damage here. When it gets, it'll start wasting away because of the damage. And because these guys will still remain for a while because they are actual cells, this is going to allow for this axon to figure out, hey, I've got this little tunnel and this is where I'm supposed to go. And so it can regenerate. And that's why in the peripheral nervous system, it may regenerate. Not always, but it usually does. And in the central nervous system, regeneration is unlikely. Now this slide, again, probably shows it a little better than my kindergarten drawing up there. So you get this site of injury of an axon. I cut myself, and so this axon's still there. This part of it that's on this side will start wasting away and start disappearing, but the Schwann cells are going to still be there. And they'll stay for a little bit. And so now I've got this little tunnel that allows this neuron to know where it's supposed to go, and it regenerates.